Hello yes, now we are going to see about CMOS inverter. The CMOS inverter is a microscopic transistor based logic gate circuit on a chip that inverts the signal, digital signal. Okay. The MOS, that is metal oxide semiconductor logic gates, use paired PMOS, that is pull up network, and NMOS, that is pull down network transistor to create high speed low power digital circuits. Okay, they are the foundation of modern ICs, that is microprocessor, memory, and ASICs, that is application specific integrated circuits. Due to negligible static power, high noise immunity, and high integration density, commonly used in battery powered devices. The key aspects of CMOS logic gates are structured, that is comprises a full up network, that is PUN, of PMOS transistor connected to VDD, and a pull down network, that is PDN, of NMOS transistor connected to ground. At a time, only one network conducts, ensuring minimal power consumption except during switching. It is to design basic logic gates includes an AND, NOR, AOI, and OAI combinations. The key advantage of CMOS is low power, high noise immunity, high fan out, and wide supply voltage range. The operation of the inverter, here the input is A, that is denoted by 0. The PMOS will on and NMOS is off. Therefore, the PMOS is closed switch and NMOS is open switch. Therefore, the output VDD flow to PMOS while the Vout equal to VDD. And then second condition, the input is 1, therefore the PMOS is off and NMOS is on. In this condition, the output is grounded through the NMOS. Therefore, the Vout equal to 0. Here, the CMOS act as a inverter because the input is 0, the output is 1. The input is 1, the output is 0. Therefore, the CMOS gives output is always complementary. Therefore, it is called complementary metal oxide semiconductor devices. This is the VTC, that is voltage transfer curve of CMOS inverter. Here, the Vn is equal to 0, therefore Vout equal to VDD. At this time, the NMOS transistor off and PMOS transistor is on. And then second condition, that is Vn equal to VDD. At this time, Vout equal to 0 volt. Here, the NMOS is linear mode and PMOS is cutoff region. In this curve, the C is the midpoint voltage, that is called Vm. In this condition, both transistors are in saturation region because the PMOS is coming from saturation to cutoff, and then NMOS transistor is cutoff to saturation region. Therefore, in this point, that is region C is always midpoint voltage. Both the transistors are saturated in this region. The CMOS families are 4000 series. It is operates over a wide voltage range 3 volt to 18 volt, and then 74HC, 74AC, that is 2 volt to 6 volt standard fast CMOS, that is high speed CMOS, and advanced CMOS often used for logic function in digital circuits. Then 74LVC, that is 1.65 volt to 3.3 volt, that is low voltage very fast ICs. The key reason preference for the CMOS is extremely low power consumption. The CMOS inverters only consume significant power during switching, as one transistor is always off in a steady state, making them ideal for battery powered devices. Then second one is the high noise immunity. Due to rail output swing 0 to VDD, they offer large noise margin, allowing them function reliable and noisy environment. And the third key point is high packaging density. Due to the small size of MOSFETs and low heat generation, millions of transistors can be integrated onto a single chip. And then high input impedance. Here, they draw almost no current from the driving stage, allowing for fan out. And finally, fast switching speed. They offered balanced rapid switching capabilities essential for high performance computing. Therefore, here referred the CMOS inverter.